This is another part of my problem series. In this video, I'll be using loop analysis and Thevenin's theorem. Once I am finished with this series of problems, I'll be posting them in my stand store at this web address. Our task is to find a V0 in this circuit using Thevenin's theorem. Firstly, we need to determine the open circuit voltage V0. To begin the process, we remove the 2K ohm resistor. The open circuit voltage at this point is VTH, our Thevenin voltage. The Thevenin resistor is then found with the sources in the network removed. That is, voltage sources short-circuited and current sources open-circuited. Let's find the Thevenin voltage first by letting the voltage drop across the 4K ohm resistor be V1 and letting the voltage drop across the 3K ohm resistor be V2. Then VTH is equal to the sum of V1 and V2. We now need to determine these voltages. We know that the current through the 4K ohm resistor, call it I1, is 4 milliamps due to the current source. Then clearly Ohm's law tells us that V1 is equal to I1 times the 4K ohm resistor, which is equal to 4 milliamps times 4K ohms, which is equal to 16 volts. To find V2, we need to know I2. And Kirchhoff's voltage law around the loop I2 yields this equation: minus 12 plus 6K ohm times the quantity I2 minus I1 plus 3K times I2, which is equal to 0. We know that I1 what I1 is, so we can plug in 4 milliamps into our equation, and it becomes minus 12 plus 6K ohm I2 minus 4 milliamps plus 3K ohm times I2, which is equal to 0. We know that this is the Kirchhoff's voltage law equation, so all terms in this equation are going to be voltages because we built the equation using 1,000 ohm resistors and milliamp currents. Then I'm going to unclutter the equation to give us something easier to read. That is minus 12 plus 6I2 minus 4 plus 3I2 equals 0. This gives us one equation with one unknown, I2. Therefore, we can quite easily solve for the value of I2. Collecting like terms, we get 9I2 on the left-hand side of the equation, and we'll bring all of our whole numbers to the right-hand side of the equation, which change from negative numbers to positive numbers and adds up to 36. We can now solve the equation for I2, giving us I2 is equal to 4 milliamps. Now, V2 is just a voltage drop across the 3K ohm resistor, which is 3K ohm times 4 milliamps, or 12 volts. This seems odd. We have a 12 volt power supply feeding into a 6K ohm resistor. You would think there is some voltage drop across the 6K ohm resistor. Upon closer examination, though, we see that the current through the 6K ohm resistor is I1 minus I2, or 4 milliamps minus 4 milliamps, which is equal to 0. So the voltage drop across the 6K on the resistor is 0, meaning V2 is definitely going to equal the same voltage as the power supply, 12 volts. Finally, we can solve the equation for VTH, which is 6 volts plus 12 volts, which is 28 volts. The Thevenin equivalent resistance is found by zeroing all sources and looking into the open circuit terminals to determine the Thevenin resistance, RTH. From the network, we see that the 6K and the 3K ohm resistors are in parallel, and that combination is in series with the 4K ohm resistor. Thus, RTH is equal to 4K ohms plus 3K ohms in parallel with 6K ohm, which equals 6K ohm. Therefore, the Thevenin equivalent circuit consists of a 28 volt source in series with a 6K ohm resistor. If we connect the 2K ohm resistor to this equivalent network, we obtain this circuit. V0 is the voltage drop across a 2K ohm resistor, which we can find using voltage division, which gives us V0 equal to 7 volts. Hey there, tech enthusiasts and smart home aficionados. I'm thrilled to announce that I'll be diving deep into the world of home automation in an exciting new series of blogs and social media posts. Get ready to transform your living space into a futuristic haven of convenience and efficiency. In the coming weeks, I'll be sharing my insights, reviews, and tips on the latest smart home gadgets and systems. We'll explore cutting-edge products that will revolutionize the way you interact with your home, from AI-powered assistants to energy-saving devices and advanced security solutions. If you are ready to elevate your living space with home automation, now is the perfect time to transform your home into a smart, efficient household. In order to explore an incredible range of innovative products that cater to all your smart home needs, simply go to this web address. Don't miss out on exclusive discounts available for a limited time. Take the first step towards a smarter home and discover how easy it is to enhance your lifestyle with cutting-edge technology. Your dream home awaits you. And I would remind you that there is no cost or no charge for simply looking at what's available. Remember, this video has been brought to you by PSPT, where you will find electrical training videos when you go to this web address, which will also give you a copy of my free 50-page crib sheet that you can use while viewing any of my courses, or just keep it handy during your everyday work. Also remember from my previous videos that you can obtain the latest discounts on battery systems at these web addresses: EcoFlow, Blue Eddy, Anchor, and Jackery. These sites not only give you unique battery systems that you can power anything from cell phones to laptops to a complete backup system for your home. Just go to these sites and see what they have to offer. There's no cost or obligation to just browsing.